All right, hey guys, Mr. Fortin back here. I'm very, very sorry about this, but I actually just decided to bail on that problem because it's not that I didn't figure out how to do it. It was a puzzle for me too. But what I wasn't looking at here is that actually proofing this one is going to require Friday's class. In Friday's class, you're going to learn the exterior angle theorem. So this is an exterior angle out here. And then these two things right together, these two angles here, this large angle here would equal the sum of these two. So you could prove that all four of these angles are congruent. So anyways, we don't know the exterior angle theorem yet. So I just changed your homework. Number 31 is not on there. Number 25 is now. I really apologize for this, but hey, I wanted to get you guys a proof. So we're shifting to this proof right here. I looked at this one yesterday. I wasn't crazy about it. So that's why I didn't put it on your homework. But now I'm regretting it now because you would know how to do this one. You don't know how to do the other theorem yet. So I'll do the proof yet. So let's go ahead and prove this one. Should be slightly more straightforward, even though I'm not really crazy about it, because you might go the wrong direction with, and that's fine. You can still recover and prove it here. So let's go ahead and set it up. Statements, reasons. But first thing, copy down the given premises. Copy down what you know, what you're trying to prove. So here we're given that angle ABD, which is right here, is congruent to angle AED, which is right there. Okay, interesting. What is the thing that we need to prove on this one? We need to prove this, right? We need to prove that angle C, which is right here, is that angle. Can we deduce this, that angle has to be the same as that angle right here? What do we notice? Oh, look. It looks like we got this going on, a triangle right here. Look it out. We have multiple. We have like one triangle there, another triangle there, another triangle there in the diagram, a big triangle here, another big triangle. So sometimes diagrams are hard to see. This triangle and this triangle are probably the two triangles to get us through the key of the problem here, because we have an angle here, we have an angle there that we're trying to get congruent. They're part of this triangle and part of that triangle. So we got to think, what's the theorem that we had today that involved two triangles? That's where my brain went with it. But anyways, let's maybe start getting some ideas down on paper or some statements down on paper and see where this goes, right? Use a chain of reasoning to get to us here to prove that angle C and angle F must be congruent here. So here, our given premise, angle ABD, congruent to angle AED, and that's our given premise. And then step two, we have here, okay, so I can get that those two angles are congruent. How? How can I get these two angles are congruent? Let's think backwards. Well, if I knew that this angle were congruent and to this angle, right, that angle to that angle is congruent, and I know that angle is congruent to that angle, then I would know that those two angles were congruent, okay? So the theorem that I want to use eventually here, I think in this proof, is if two angles in two different sets of triangles are congruent to one another, then the third angles are congruent. That's how I'm going to do it here and prove this one for you guys today. So step two is this. I'm maybe going to go the direction of saying that this angle is congruent to this little angle right here. Okay, they're the same measure, but this one doesn't, the sides aren't as long. So that's one called a little angle. Anyways, but we're gonna say they're congruent, right? Because as long as their measurement's the same, they're congruent angles. So here and here, we're gonna say those are congruent angles. Why are these two congruent angles? Well, they're arranged vertically from one another, vertical angle theorem. Or vertical angles are congruent, right? Is how your book does it. That's how I like to abbreviate it here. So we got angle BDC congruent to angle EDF, and that is vert angles congruent. Step three, okay, so now I just got to work on getting that angle, right? This angle congruent to this angle. I'm gonna work on that. Once I have that pair, and then I have this pair, and then I can say that pair is congruent as well. So how am I gonna get that angle congruent to that angle? Well, they would both be supplementary to these two angles that are congruent to one another. Perfect. We said that as our given premise. So let's start working on that. Let's start working on saying that those two angles are supplementary and these two angles are supplementary, okay? We can't just say that they're supplementary, because that definition of supplementary angles is that angles that measure 180 degrees. So remember, the way we can say that plus that equals 180 is actually the angle addition postulate. Yes, 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 yes. We have to use that. So let's use that here. Measure of angle CBD plus measure of angle ABD equals 180, okay? And measure of angle AED plus measure of angle DEF equals 180, okay? Reason for that? Part plus part equals whole when it's a straight angle. Part plus part equals whole, and that's a straight angle here, so that is the angle addition postulate. Next step, right? We want to say that this is supplementary to that, and this is supplementary to that, because we know we have that theorem. If two angles are both supplementary to congruent angles, then they are congruent to each other. Remember that? That's going to help us with future chains of reasoning that we have in establishing more facts here. So we can say through definition of supplementary, here we've angle addition postulate got us there. Now we can say through definition of supplementary that angle CBD and angle ABD are supplementary, and angle AED and angle DEF are supplementary. And then finally, step 5, we can say angle CBD is congruent to angle DEF. And reasoning for that is that if two angles are each supplementary to congruent angles, then they are congruent to each other. There we go. Okay, so now we have checked this off the list, that those two angles are congruent, and we've checked that off the list, that those two angles are congruent. So now we have a triangle up here, a triangle down there, and when we know that we have two congruent angles to the two angles in another triangle, the third angles have to be congruent to one another. That was corollary 1. It's what we started this first video with, and we got this down as our answer. Angle Angle C is the remaining, the third angle here. Yes, that's got to be congruent too. So we have a check mark here, a check mark there, check mark here, check mark there. Therefore, we can deduce that those two, check the boxes there, they're congruent to one another here. And that's the final video. Thank you guys so much for watching. Stay tuned for the answer here, the reason here. I'll write it down. But thank you for watching. I think you know the answer now here if you're watching here. If two pairs of angles in two triangles are congruent, then the third pair are congruent as well. All right, email me if you have any questions. Good luck with the rest of the problem set. That's a 6-step proof. Got it done. Again, don't do number 31. I will see you guys tomorrow. Bye.